Hey, what's going on? Welcome back. Patrick here from All Things Mathematics, and moving on to the next example. On the test, we have to differentiate each of these functions here. So notice they're all in different formats. We're going to be using different rules here: chain rule, quotient rule, product rule. I'm assuming you've watched all the lecture videos regarding these different rules, and you've gone through all of the different scenarios that can come up. So I'm going to go through these a little bit more quicker, assuming you already have that foundation. So starting with the first function, we have in brackets the third root of x plus 3x, and all of that is to the power of 4. Now I'm actually going to rewrite this function first. This third root of x, I'm going to rewrite it as x to the power of 1 over 3, like that, plus 3x to the power of 4. So hopefully you can recognize that we're going to be using the chain rule here, right? Because we have this outer function, power of 4, and then we have this inner function, x to the power 1 over 3 plus 3x. And if you remember, if you have a function, like an outer function and then an inner function, like this, and you want to take the derivative of it, what we do is we take the derivative of the outer function first, keep the inner function the same, and then multiply by the derivative of the inner function, like that. So applying that here, the derivative, we would bring the 4 down. The 4 is the outer function, the exponent for it. And then we're going to keep the inner function the same, subtract 1 from the exponent, so that would be 3, and then we multiply by the derivative of the inner function, right? So we take the derivative of this now. So x to the power 1 over 3, bring the 1 over 3 down, subtract 1 from the exponent. 1 over 3 minus 1 is negative 2 over 3, plus 3, like that. And then from here, there's not much we can do to simplify it. What we can do, this negative exponent, we can maybe make it look a little bit nicer. So x to the power 1 over 3 plus 3x to the power of 3. Bring the negative exponent down, so we'd have 1 over 3, x to the power of 2 over 3, like that, plus 3, right? But there's not much we can do here to simplify. If we wanted to bring the radical back in, the third root of x would still be there, plus 3x to the power of 3. And then this would be 1 over 3. Now this x squared, or x to the power 2 over 3, we could rewrite that as the third root of x squared, right? That's another format that this can be in. So maybe your teacher expects you to take any rational exponents and rewrite them as radicals. Basically what happened here was this x to the power of 2 over 3. It's like rewriting it as x squared to the power of 1 over 3, which is basically like the third root of x squared, right? So that's what I did here. I took that, converted it. This 3 over here still stays on the outside. All right, so different formats that the derivative of this first function can be in. Now moving on to part B. So here we have the first bracket, 1 minus 2x cubed plus x squared in brackets times this second bracket, 1 over x cubed plus 1. Now what I'm actually going to do before differentiating it is I'm going to take that 1 over x cubed. Personally, whenever I see just a constant, like if I have a rational function and there's only a constant in the numerator, I like to bring whatever's at the bottom up. So I'm going to rewrite that as x to the negative 3, and that's going to be plus 1, like that, right? So just rewriting the function. And then from here, because there's these two brackets that are multiplying, I mean, you can expand everything. The expansion is not too bad. But what I'm going to do is I'm going to use the product rule, right? Two functions multiplying, if you remember. If you ever have two functions multiplying, the derivative would be the derivative of the first function times the second function plus the first function times the derivative of the second function. So we take the derivative of this first function, which would be what? Negative 6x squared plus 2x, like that. Keep this other function the same. And then what happens is we keep the first function the same, 1 minus 2x cubed plus x squared, multiplied by the derivative of this. So what would happen? We bring the negative 3 down and then subtract 1 from the exponent, like that. And then the derivative of 1 is just 0. And so from here, making this look a little bit nicer, let's take any negative exponents, turn them back into positive exponents like this. The x to the negative 3, that'd be 1 over x cubed plus 1, plus this bracket 1 minus 2x cubed plus x squared. That's going to be multiplied by negative 3 over x to the 4, like that. Okay, and then if you want to simplify from here, I mean, you can expand if you want, and then see if there's any like terms that are going to be there. So if we do expand this, like negative 6x squared times 1 over x cubed, that would be what? Negative 6 over x, plus 2x times 1 over x cubed, that would be 2 over x squared, because an x and an x would cancel out, we're left with 2 x's. And then the 1 multiplied, everything stays the same there, plus 2x. And then over here, you could distribute this negative 3 over x to the 4 inside this bracket. So we'd have minus 3 over x to the 4 plus 6 over x minus 3 over x squared, like that. And then from here, you could look for some like terms. So notice here we actually have this negative 6 over x and positive 6 over x. So those are actually going to net out to 0. And then notice here, we have a like term in this, right? They have the same denominator. So 2 minus 3 would be negative 1. And then I think that's pretty much it, right? That's all that is. Those are all the like terms. So this would be negative 6x squared plus 2x. 2 minus 3 is negative 1 over x squared. And then we're left with this minus 3 over x to the 4, right? So that there would be our final answer, our final derivative for this first function. So again, different ways to do it. You could have also expanded at the beginning, simplify the like terms, and then ended up getting this. Whichever way you do it, make sure your final answer simplifies to that expression. Now moving on to part C, we have f of x equals 1 over x to the power 4 plus 1. Now different ways that you can do this one. You can do the quotient rule on this. However, personally, and I've mentioned this in a previous one earlier in the video, whenever I see that there's only a constant over here, I like to take the expression that's in the denominator and bring it up. Okay, rewrite the function, and then from there use the chain rule to derive it, but only if there's a constant. So if there was like an x here, right, then I would do the quotient rule for sure. I wouldn't bring this up. And then, I mean, you can bring it up and then do the product rule. I think we've done examples like that in the lecture videos. But usually if there's a variable in the numerator and denominator, then I'll just do quotient rule. However, if there's only just a constant, then I'll take the expression and in the denominator and bring it up. So what would happen here is this one would stay, but then this x to the 4 plus 1, it's like to the power 1 here. So if we bring it up, it goes to the power negative 1, like that. And then this one we actually don't have to write. However, I wrote it just in case maybe there was like a different constant like 2 over here, right? Then you would have to write the 2. So just writing clearly everything in this rewritten format of the function. And then yeah, from here, let's do the chain rule, right? So we would bring this negative 1 down. So there's like an inner function, and then this power negative 1 is the outer function. Bring the negative 1 down. So negative 1 times 1 is negative 1. Keep the inner function the same. Subtract 1 from the exponent, that would be negative 2, and then we have to multiply by the derivative of the inner function. What's the derivative of x to the 4 plus 1? 4x cubed, like that. Okay, and then from there, to make it look nicer, this whole expression, because it's to the power negative 2, let's bring that down to the denominator. Negative 1 times 4x cubed, that's negative 4x cubed, that stays in the numerator. And that's going to be all over x to the 4 plus 1 to the power of 2, like that, right? And then there's nothing we can do to simplify this. That right there would be your final derivative. Now let's say instead that you use the quotient rule on this. So if you remember the quotient rule, if you have two functions, g over h, the derivative is basically the derivative of the top times the bottom minus the top times the derivative of the bottom all over the bottom squared. So what we would do here with the quotient rule, take the derivative of the top, the derivative of 1 is just 0, times the bottom function, x to the 4 plus 1, minus the top, which is 1, times the derivative of the bottom function, x to the 4 plus 1 is just 4x cubed, all over the bottom squared. Like that. This goes to 0, and then this ends up being negative 4x cubed over x to the 4 plus 1 squared. So notice we got the exact same solution when we did it with the quotient rule versus when we did it with the chain rule. Again, this is my preferred method. If I just have a constant, I'll just bring everything to the numerator, do the chain rule, but you could also do the quotient rule if you feel more comfortable with that. Quick little intermission here. I wanted to mention a few things and we'll get right back into the video. Number one, if you're watching this on YouTube, you can go to the description box and there's a link that will take you to my website, allthingsmathematics.com, and there you can find all of the videos organized by chapter, by section, and there's also tests that you could try at the end of each unit. Number two, if you feel like you need tutoring at any point, I'm tutoring students 7 days a week over Zoom, both high school and university students, one-on-one and in groups. My contact details are on the website. You could text me and we could book a session. And finally, if you feel like you're getting any value from this video, if you could please like the video and subscribe to the channel, hit me up on all my socials. It does help me out a lot. If you feel like any of your friends can benefit, feel free to forward the website to them as well. And back to the video we go. And then finally, moving on to part D, this one is going to be quite hectic. So here we have 2x plus 1 times 3x minus 1 to the power 2, and then 4x plus 1 to the power of 3. Okay, so notice that to expand all this would take us forever, right? Because we have 2 brackets of this and then 3 brackets of that. Okay, so in total, we would have 6 brackets. That would take us forever to expand. Here we're going to have to use the product rule, but notice that it's a product rule with 3 functions, right? And so if you remember from the lecture videos, let's say that we have 3 functions. Actually, you know what? I'm going to write this as like, let's say m of x. And we have 3 functions here, f times g times h, like that. Well, the derivative of a function like this, we take the derivative of the first function, multiply it by the other 2 functions left as is, plus the first function left as is times the derivative of the second function times the third function left as is, plus first function left as is, second function left as is, times the derivative of the third function. Right, and then we're going to have to simplify it with factoring. So it's going to be quite hectic. So let's be careful, super careful with our algebra here. So first thing we would do, take the derivative of this first function. Derivative of 2x plus 1 is just simply 2. Okay, and then we leave the second function as is, and then the third function as is. And then it's going to be plus 2x plus 1, like that. And then what happens is we have to take the derivative of this function. Notice we're going to have to do the chain rule on that, right? Because we have an inner function 3x minus 1 to the power of 2. So that power of 2 is the outer function. So we would bring the 2 down, keep the inner function the same, subtract 1 from the exponent, then multiply the derivative of the inner function, 3x minus 1 is just 3, like that, times the third function, left as is, like that. And then just to save some room here, we'll have plus first function, left as is, times the second function, left as is, and then we have to multiply by the derivative of that third function. We have to do the chain rule on this third function as well. Bring the 3 down, keep the inner function the same, subtract 1 from the exponent, multiplied by the derivative of the inner function, like that. right? So that's what the expansion is going to end up being. And then simplifying this a bit, all I did here was, like, for example, this 2 times 3, right? I made it equal 6, and then I kept these terms the same over here. And then this 3 times 4, that ended up being 12 right there. And then I kept these terms the same. And so now what we're going to have to do is simplify this. And if you remember from the lecture videos, I've done examples like this. We have to simplify by taking out common factors. So let's start with the numbers that are in front. So we have the 2, the 6, and the 12. Common factor is a 2 that we could take out. And then notice that we have 3x minus 1 squared, 3x minus 1 to the power 1, and then 3x minus 1 squared. You always take out the lowest exponent, which is this power of 1. So we would take out a 3x minus 1 to the power of 1, like that. And then the next term, 4x plus 1 to the power of 3, 4x plus 1 to the power of 3, and then 4x plus 1 to the power of 2. So we would take out that exponent 2. That's the lowest exponent. And so what would we be left with here? So let's be super careful. We took out the 2, took out one of the 3x minus 1s, but there's 2 of them here, so there would still be a 3x minus 1 there. And then 4x plus 1 squared, there were 3 of them, so there's still a 4x plus 1, like that. Plus, from the 6, we took out a 2, so there's still a 3 left. There's still the 2x plus 1 left, right? We didn't take that out, so that would still be there. The 3x minus 1 to the power 1, we took that out, so that went away. And then 4x plus 1 to the power of 3, we took out only 2, so there's still a 4x plus 1 left there, right? Because we only took out 2 of them, but there are 3 of them. And then finally, this third term, took out a 2 from the 12, that would be 6. 2x plus 1 is still there. 3x minus 1 squared, we only took out 1 of them, so there would still be a 3x minus 1 floating around. 4x plus 1 squared, we took out the 4x plus 1 squared, so that would go away, right? And so we'd end up with this large bracket right here. And then from here, all that is left to do is to expand this large bracket, right? So these factors here, let's keep as they are. And then the expansion here is going to be quite crazy. So let's see what happens. So we'll have 12x squared minus 4x plus 3x. That would give us minus x minus 1 plus 3. The expansion here would be what? 8x squared plus 6x plus 1. Right? I'm like simplifying those middle like terms all in one step, and then that's going to be 6 over here, 6x squared, negative 2x plus 3x, which is positive x minus 1, like that, right? And so from here, you would just have to expand everything and then simplify the like terms. And so when you expand everything, like bring the 3 and the 6 in, simplify the like terms, you'd end up with this quadratic 72x squared plus 23x minus 4. And from there, you could leave it like this. Actually, though, this quadratic, it does actually factor. So if you, so 72x squared, if you decompose this, so two numbers that multiplied, 72 times negative 4 would be what? Negative 288. Two numbers that multiply to negative 288 and add up to 23 would be 32 and negative 9, like that. And so decomposing that middle term with those two numbers, minus 9x plus 32x minus 4, from these two you could take out a 9x and you'd have what? 8x minus 1. And then from here you could take out a 4. You'd have 8x minus 1. Then you could take out an 8x minus 1, and you'd have 9x plus 4, like that, right? So this bracket here can also factor into these two, right? If you want to have everything in factored form. A lot of times this this expression that's left over, a lot of times it won't factor. Sometimes there may be like an extra variable floating around that you could take out, or you could take out like a common factor number. But notice there was no common factor numbers between 72, 23, and 4 that you could take out. So a lot of times you can factor fully, but it's kind of rare that it will factor by decomposition into 2 brackets like this. But nevertheless, it does. So different formats that this final answer can be in. So again, this one was pretty hectic, but doesn't mean that it can't show up on your test. And that is the end of the video. Hopefully you enjoyed that. If you want to find more videos like this, you can go to my website, allthingsmathematics.com. Over there, all my courses are organized for both high school and university. All the videos are organized by chapter. Also, if you have any questions, you can hit me up. My contact details are also on the website. Enjoy your day, and I'll catch you in the next one. Peace out.